Here we go. We're in 3.1 and we're on number 2. So it says Scott was proud of the money that he raised last year. This year, or to take it to a whole new level. He plans to look at the total number of push-ups each day. 5 push-ups, then 7 push-ups, then 9 push-ups. Then here he's doing total 3, then 8, then 15, 24, and so on. And then here this year he's actually doing a day, which if you look, we already have this okay, so since we already figured out this function here, that means we already figured this out. And so when you're figuring out functions, okay, when you're like playing around with them, you're still in the area of playing around with them and not, I haven't given you a method where you know how to go from A to B. So here, what we did was we thought we knew that it was a quadratic because it has a second difference, right? And then you said, okay, well, if I plug in 1 squared, man, that's 3. So then you thought, oh, well, let me add 2 more. And I plug in 2 squared, and then you're like, no, but because now you have to add 4. And then 3 squared, now you have to add 6. And then you saw the pattern here. So sometimes when you're trying to find a pattern, the pattern actually is 2 patterns. It's 2 different patterns here and here. And that makes sense, right? Because sometimes we're just going to add those 2 patterns together to come up with it. So I'm going to take this thing here and I'm going to copy this because this pattern goes all the way down here to our new table. This function goes here, right? And if you notice, this function also goes here, right? We know that. Okay, so with that being said, it says how many push-ups will Scott complete? And then this is the next slide, right? How many push-ups will Scott complete on day 4? And how did you come up with that number? And I know I saw a couple of you, and we're not talking about the old last year, we're talking about this year. And so clearly here, this is going to be 24, right? That's not anything new, right? So that's going to be 24. Give me a second. Let me grab something over here. Okay, so then that's going to be 24. And then, so then we fill in that table, not a big deal. How many total on day 4? So now they're talking about this column. So total push-ups completed for the month. Okay, so wait, what? So how many total push-ups has he completed for the day? How many total, how many would go here? So here, okay, sorry, let me just go back this up. So this is this year. Ignore this side. This is him last year, but now we want to talk about this year. So he's basing it off this. So if you wanted to put this, you would put a big N is equal to Mn. Gn is equal to Mn, M of n. T of n is the total number of push-ups for this month. How many push-ups has he done for day 1? 3. This month, it's just 3. Does that make sense? Okay. I know I'm still cutting off, but I'm just going to keep going on so that we can record this and then you guys can go back because I don't know what to do. Okay. Okay. So is everybody okay with this? Is in the chat. Yeah. Okay, good. So how many total push-ups does he have? Okay, now bring this is all not here. Okay, how many push-ups does he do on day 2? 8, right? Right? So how many total push-ups here? Yes. Why is it 11? Where does the 11 come from? Where you all told me to put 11 here. Where did 11 come from? Yeah, it's 3 plus 8. 3 plus 8, right? Okay, if that makes sense, how many total push-ups do you get for day 3? How many total push-ups will you get for day 3? We got 2 different numbers. Some people are saying 23 and some people are saying 26. Total push-ups is total push-ups completed for the month. For the month. Okay, good. Now it's 26. All right. So 26 because 3 plus 8 plus 15 is 26. Does that make sense now? Very good. Okay. All right. I feel like you guys are getting this now. Let's move on. What about this day right here? Yeah, some people are like, let me add these all together. Some people are like, no, I'm just going to add 24 to 26. That gives me 50. Okay, so now we know how many push-ups there are, and we're all feeling pretty darn good. I'm going to go back and fill out this from our previous chart. So for 5, it was 11 and 35. So that should be 11 here, 35. And because these 2 columns are equal, then this is 35. And just for fun, I'm going to put 85 here. Okay, is everybody okay with that? Okay, so I figured it out. Push-ups on total day 4, we're good. Everybody okay with this? Everybody good? Okay, very good. So let me move on then. So then the next slide says, okay, and then it's really small. I can't read that, so I'm going to just jump over here. This says, how many total push-ups did Scott complete for the month on day 4? We figured that out. That's 50. I can't write. Hold on a second. Okay. So 50 push-ups. And then it says, write a recursive equation for T of N to represent the total number of push-ups Scott will complete for the month on the given day. Hold on a second. Excuse me. Okay, so now when we're asking this, okay, recursive, there's 2 parts to recursive, okay? there's two parts to recursive. The first part is your starting point. So my starting point is however many push-ups I had on day 1. What's the total number of push-ups that I had on day 1? 3. So I'm going to put T of 1 equals to 3. Now you should remember from unit 1, this is literally the point 1 comma 3. So if you're seeing this and you're like, this is still foreign to me, Miss Johnson, get it less foreign by starting to write and talk about these things. Okay. The next thing is actually called the rule. So the starting part, this is how you get from one to the next. Okay. So from here to here, from here to here, what did we add? From here to here, what did we add? Oh, we added this 8. And from here to here, what did we add? Oh, we added 15. And from here to here, we had this. And from here to here, we added this. Is there a generic way to talk about this column? How much did we add? How much did we add? How much did we add? 50 push-ups on number 1. What? I don't understand your question. Someone said, why? Wait, why is it 50 push-ups on number 1? Number 1? This one? No, I don't know. I don't understand your question. Can you give me more? So yes, so I'm just going to add, we're going to say T of n is 1 plus, and then I'm going to write n. So in regular terms, this is how you say previous, and this is how you say. The next term is you add the number. How do you figure out how many push-ups you did per day? Write this n squared plus 2n on the end of this because that's how many I added given that day. Does that make sense? Oh, okay. Check, because we already said that on day 4 I should. So this is me checking my answer. So T of there it goes. So T of 4. Now let me just make this giganticer. Here, here, and then let's make this. Oh, there it goes. It's gonna be nice. Okay. So instead of putting an n right there, I'm going to put a 4 again. So I'm going to go 4 minus 1 plus 4 squared plus 2 times 4. Okay. And it's still taking a long time. So I'm going to keep going with this. T of 4 minus 1. I'm just copying this equation right here. Plus 4 squared plus 2 times 4. This is me just checking my answer. Wow, what did it do right there? That's so interesting. I don't know why it's making one thing. Oh, there it goes. Okay, so then I'm just going to simplify. Hey guys, what's 4 minus 1? Yeah, it's just 3. So I'm going to copy this whole thing. And I'm going to put it down right below it. Right? And you told me that 4 minus 1 was 3, right? So I could just erase all this and put a 3? Yeah, Miss Johnson. Okay, wait. What's 4 squared? Yeah, 4 squared is just 16. So I'm going to erase this part and just put a 16 there. And what's 2 times 4? Yeah, it's 8. Okay. So the only thing that I don't understand is what is this T3 business? Well, T3, according to this, is the previous term. Since I'm looking for T4, I'm looking for this number, I'm pretending I'm calculating. What would T3 be? What would T of 3 be? Yeah, someone says 26, Miss Johnson? I don't know. Why would you call it 26? Well, because this is the T column, correct? On day 3, that's 26. That's correct. So I'm going to rewrite this and oops. I'm going to rewrite this, copy this right here. And then you said this was 26. Thank you for enduring my painful typing. So there's 26. Okay. I'm hoping that when I add all these things together, 26 plus 16 plus 8, I hope it's 50. Because if it's 50, then this answer right here that you asked me, Ms. Johnson, recursive, it's right. So let me continue. So 26 plus 16 is 36, 42 plus 8 is 50. Yay, Miss Johnson. So guess what? I can write this is equal to 50. So Miss Johnson, all of that to say what? Well, these two are equal. 50, 50. It's the same. So because they're the same, that means my answer here is correct because it matches the table. Something all that work to check your answer. Yeah, I mean, I like checking my answer. That's like one of the advantages of math, right? Knowing that your answer is your answer. And I need to make this a tad bit bigger. Okay, it says without finding the explicit equation, make a conjecture as a type of function that would represent the explicit equation for the total number of push-ups that he would complete. Okay, so here, follow me on this. Here, this was a row of differences. This would be linked to, right? Have the same first set of differences. It had the same second. Set of differences. So that's a question. Do you think this is going to be linear? Just oh, got it. Okay, so thank you for your patience. All right, so number 5 says without finding the explicit equation, make a conjecture of the type of function. So here, this function is quadratic because it's squared. The reason why it's squared is because if you go all the way back up to our top, no, I went too far. Here is because it went to the second, some people call this the second order of differences because it's not the first set of differences, it's the second one. So the linear one, when you added it to, and you made a total, it would be quadratic. So what happens if you take a quadratic and you add it to another one? What kind of function do you think this would be? What kind of function do you think this would be? Any guesses? So someone says linear in the chat, and let me just see. Can you add 3? 3 plus what gives you 11? Yeah, it's 8, right? So this is plus 8 right here. Sorry, we're going to do the best that we can. And then here, to get from 11 to 26, what would you add? Yeah, it's 15. So boom, right there. What do you know? What do you automatically know? Boom, 8, 15. It's not linear. If it was linear, then you would see 8, 8, 8, 8, 8, 8, 8, 8, 8, all the way through, correct? Right? It's not linear. So I'm just going to keep going just so that we can figure out what else it could be, because eventually we're going to want to know. So I don't think it's linear. Any other guesses besides linear? Not linear because the change wasn't constant. Okay. And if you don't know what that means, it just means that that we weren't adding the same number of push-ups every single time, right? We didn't add the same number of push-ups. So if you look, this was linear. You should be able to see this and be like, oh yeah, up to over 1, up to over 1. Do you guys all see my line? Up to over 1. So even though this says it in numbers, my brain is picturing this line, okay? Okay, this one, we already knew that it wasn't going to be linear because we were adding a different number every single time for the total number of push-ups. For this one too, I already knew that it wasn't going to be linear because we were adding a different number to get a total number of push-ups. So someone says, hey, Ms. Johnson, it might be quadratic. Okay, good. It could be quadratic, or it could even be some other higher power. And we'll see this. So we just knew it wasn't linear. How does the rate of change for this function compare to the rates of change for the function in Jumpstart and problem 1? And we've been doing that over and over again, right? If you look at here, we were adding by 2, by 2, by 2, by 2, right? Here we added by whatever it was, by 5, by 7, by 9, by 11. We were adding the odd numbers. Here, if you continue off, what would be the next two numbers that I would add here to get to 50, 26 to 50? So one would be like, oh, it's 24. And the next number, sorry, these aren't so even because my iPad is still not updating. Let me see if it is. Nope. And then this would be 35. And you're like, hey, Ms. Johnson, these numbers here are these numbers here. Exactly. So if your differences are quadratic, what would you think this is? And someone in the chat says, it might be cubic. So we say cubic because we are adding, or the change is quadratic. Does that make sense? So wait, what, Ms. Johnson? So here, the change here was linear, right? It was plus 5. See, plus 5. Oh, actually, here, let's look here. This might be better. Here, the change here was plus 5, plus 7, plus 9, plus 11, plus 13. Where do you see these numbers? Where do you see these numbers here? Someone says, yeah, that's the push-ups per day. Good. This is what he did last year, right? So this turned out to be a quadratic function when the change is linear. Do you guys all hear that? Say that again, Ms. Johnson. So this function turned out to be quadratic. See, quadratic squared. Because the second order of differences was constant, meaning the first order of differences was linear, right? So you're saying because this was linear, then the function was quadratic? Yeah, be more specific. Because the change was linear, the change was linear, then the function is quadratic. So you'll see this again in calculus. I'm trying to get this into your mind now so that when you get to calculus, your brain doesn't go like, what? Okay, so here, let's go over this one. What type of function were we adding every single time here? And you guys said, oh, Ms. Johnson, that's when you did this thing. You added a quadratic to the previous. Yeah. So because I'm adding a quadratic, what do you think might be the function, type of function? And someone says, oh, it could be cubic. Cubic means to the third, right? And then similarly, if you did it again, that would be quartic, which is like to the fourth and so on. Cubic because we are change. That doesn't make sense. Because we are adding, or let's do it like that. Because we are adding, or the change is quadratic. Okay, so let's continue. How does the rate of change for this function compare to the rates of change of function in jumpstart in one? We just talked about that. And then test your conjecture for problem 5 and justify that it will always be true if you can move to a generalization of polynomial functions. Okay, so what, Ms. Johnson? Okay, so I wish I could, like, how do I do this? How do I make you bigger? Do I make you smaller? Maybe I make you smaller. Maybe I make you bigger. Let's make you bigger. See if that'll work. Okay, if I make this bigger, then this, oh, I know how to do this. Forget it. I'm just gonna ignore this. Okay. I was trying to figure out a way to show this because my iPad is not working. Sounds good. Okay, so then let me get these in here really quick. So these would be adding, I'm writing the numbers that we're going up by. So hopefully you can kind of see this. Okay, so this is our first set of differences. And you guys should all say something like this. Ms. Johnson, I get it. Because these all aren't the same, and maybe I write it right here. Someone write this phrase for me. Actually, you tell me. Because all of these numbers, the first set of differences aren't the same, what do we know? Because all of these numbers aren't the same, what do we know? Yeah, very good. Okay, so let me write the first part of that. Because the first set of differences aren't the same, we know. And then you guys said it's not linear, Ms. Johnson. Perfect. I'm just going to snip that. Okay, very good. We know it's not linear. Sorry, I am going to put your guys' work in here because this is what I think is really important. Smaller, Ms. Johnson. Whatever. It's not linear. Okay, so I'm going to draw a little tiny arrow because I need you guys all to see, like, this is what this is coming from right here. So here, look, because these aren't the same, we know this. Maybe we should put this in like highlighted purple or something. I don't know. This color, purple. All right, good. Okay, if the second set of differences, right? Let me copy this. If the second set of differences, if this row right here are all the same, what would that be? If this row right here is all the same, the second row, yeah, that'd be quadratic. Okay, so I'm gonna do some subtraction. You can do it with me. You don't have to. So this is 7. So I'm gonna put that right here. You guys all see what I'm doing, right? I'll put lines in there later, but right now my iPad is, I wrote some stuff up here like 40 minutes ago, still not there. Okay, so 7, what next? 9? What next? 11? And you're like, hey, Miss Johnson, these numbers look very familiar. And I'm like, yeah, these numbers look familiar, right? You guys all see these numbers? Where do you see 7, 9, 11? 7, 9, 11. Where do you see this? Yeah, last year's push-ups per day. Very good, very good. So, okay, Miss Johnson, because this is linear, this is quadratic, so this has to be cubic, right? Yeah. Okay, so just to show you, so, and then I'll write it up here. I'll write the same thing. Okay, because I know, and this time it's not the first set of differences, because I know what? Because I know the second set of differences are not the same. What do I know? We know what? And then I'll do a different color arrow. We're trying to get this all here. Boop. Then I'll highlight it a different color so it stands out in this. Because I'm like, Miss Johnson, do you really need to color code? Yeah, because it kind of stands out. That's what I'm hoping, right? Like, look, right? Maybe I should like color these the same. What am I doing here? Go here. Yeah. Maybe that'll help you all see it. Do you guys all see that? Because these numbers aren't the same, boom. And then later on, I'll highlight this. Because these numbers aren't the same, it's that. So yeah, this is quadratic. This second line here, if these were the same, then it would be quadratic. Because it's not, it isn't quadratic. That's what we know. Very good. All right, so move this over. I have like so many things here. Oh no. No. It isn't quadratic. Oh, I know what to do. Maybe I need to shut my iPad down. Okay. Okay, so yay. Because these aren't all the same, then we know it's not quadratic. Okay, and then my last little thing here, I'll copy this guy here. Okay, do some differences with me. Oh, what happened? What is all this? What happened? That was crazy. Oops. Yeah, do some differences with me. This is going to be the number 2, and I'm going to change this color to some pinky color. Let's go with pink. This pink? Sure, this pink. Okay, now notice this 2 is going to show up over and over again, right? Miss Johnson, it's the same, and we finally get the same. And because we know that, then we say, let me go like this. Whew, this is a lot of typing, Miss Johnson. I know. Okay, let's make this smaller so you guys can all see what I'm talking about. Because we know this, and then we need to go with that pink color because that's where we did the pink color. And because we know the third set, so now we have third set. What is the third set of differences are the same? These are the same. We know what? What do we know? What do we know, guys? Yeah, we know it's cubic. Perfect. We know it's cubic. So what does that mean by it's cubic, Miss Johnson? It means it's to the third. Put that there. Typing took me forever. I appreciate your endurance here. Imagine these are all the same. So Miss Johnson, this could literally go on forever, and that's how you would find like to the 10th power. Exactly. So these are called sets of differences. And because they're sets of differences, now we know that this is going to be n cubed, right? this guy is going to be n cubed. So what I'm going to do is I'm going to now look for the function. But this is something that we're going to play around with in the future. So I don't necessarily need you to understand how to find the function today. But it's very similar to kind of what we did up here, where we play with numbers, except for now, if you think about it, there's going to be more stuff to add. But if you look, we already know, right? We already know that this is part of the function, right? This is part of our function if you think about it. Because in 11, it's 3 plus 8. And in 15, it's 3, in 26, it's 3 plus 8 plus 15. So you can kind of see our function growing in there. So let's see if we can come up with a function the next time. But just so that you know how I'm going to build this function, I'm going to start with the number 1 and I'm going to cube it. I'm going to be 1 cubed. 1 cubed is 1. That's a 3. So, oh, Miss Johnson, just add 2. Okay, kind of. And then I'm like, okay, well, 2 cubed is 8. Oh, but that's just plus 11. Plus what gives me 11? And then 3 cubed, well, that's 27. See, we're not adding that same amount, right? So we're going to have to play around with this enough to figure out how to get there. Okay, so your goal for today is to know, like, if I give you a table of values, you can tell me whether it's linear, quadratic, cubic, based on that. Okay, so your exit ticket will basically do that for you. Remember, we showed you the exit ticket earlier. It says, what mathematically, that's too much, Mr. Johnson. You went way too big. Sorry, y'all. It says, what mathematically correct statements could be made about the rate of change? Remember, the rate of change is just your differences. For the 5th difference of this polynomial, okay? When I say x to the 5th, he doesn't have a special name like cubic or quadratic. He's just the power to the 5, right? So if you wrote this out, what could you tell me about the rate of change and this 5th set of differences for this polynomial? You should be able to do that now. All right. Stop.